classifying real numbers. So we're going to look at the different categories of numbers that we've been working with so far with the operations that we've been doing. And those all fall into this category of called real numbers. We've got smaller groups, and they kind of get bigger as we go. So let's start with the smallest group that we have, which is called natural numbers. And these are your counting numbers. If you think about the numbers that you used when you started counting, either when you're watching Sesame Street, or in nursery school, or in preschool, or in kindergarten, we started with counting numbers. And if you think about when you're counting something, those are your counting numbers. And we generally start counting something with 1. So we've got a Venn diagram here on the bottom that I'm going to keep referring to. Here's the set of our natural numbers, and I've got a few in there. Natural numbers is kind of the smallest set that we work with. The next set of numbers are called whole numbers. These are our counting numbers and 0. So the only number that I'm including greater than this is just 0. So if you look here, we see our natural numbers are inside the whole number group. We've got all our natural numbers, and 0 is also included. Next we have integers, and integers are whole numbers and their opposites. So again, if we kind of start thinking about a larger group than this, we've got whole numbers, which includes our natural numbers, but then we've also have their opposites. So now we're starting to include negatives in our integer group here. So whole numbers and their opposites in the integers. Rational is any number that can be written as a fraction. So any number that I can write as a fraction is included in the rational group of numbers. So 2, I can write that as a fraction, is 2 over 1. -3, I can write that as a fraction, it's -3 over 1. 1/2, I can write that as a fraction. Clearly it says a fraction. -2/3, yes, that's a fraction. 2.25, I can write that as a fraction, 2 1/4. And 0 and 3, 3/10 repeating, I can write that as 1/3. So these are all rational numbers, noticing that I have subsets of them as I go. Now I also have this group called irrational numbers, which is any number which cannot be written as a fraction. The decimal form neither terminates nor repeats. So I have a few irrational numbers that are over here. You'll see pi in there, and pi does not have a pattern to it, and it never ends. So it's never ending, and it doesn't repeat. So there's no particular pattern to it. Cube root of 7, square root of 3, -2 times pi, the opposite of the square root of 3. A lot of roots tend to be irrational. They tend to be kind of ugly numbers. And then the larger group that includes all of them are the real numbers, and those are all the rational and the irrational numbers. So both of these are included in our real number set. So generally when I'm trying to look at a number and decide which groups it falls into, I kind of start at the largest group and then work my way down. I decide, okay, it's in the real number category, and then which one is it? Is it irrational or is it rational? If it's irrational, that's as far as I can go because there aren't any other subsets. But if it's rational, okay, am I also going to include it as an integer? Am I going to include it as a whole number? Am I going to include it as a natural number? So let's look at some numbers and classify them. So A, we're going to classify each real number. A is 7/9. So first, it's a real number because it's one of the numbers that we're used to working with. Now, is it rational or irrational? And the difference is, can I write it as a fraction or not? It's a fraction already, so clearly I can write it as a fraction, so it's rational. Is it an integer? Now, integers do not include fractions. So if I have to write it as a fraction, it's not an integer. And this one has to be written as a fraction, so it's not an integer. So it's real and rational, and that's as far as I can go. Next one, -square root of 196. Now I'm going to simplify this and see what it looks like. It's actually -14, which is pretty straightforward. So that's a real number. Can I write it as a fraction? Sure I can, -14 over 1. So then it's rational. I'm going to keep going. Is it an integer? Do I need to write it as a fraction? No, I don't need to write it as a fraction. So that includes it in the whole numbers and opposites. So it's an integer. Is it a whole number? If I need a negative, it's not a whole number, so it's not a whole number, so I stop. So it's real, it's rational, and it's an integer. Next, we're going to do the cube root of 2. Now, if you grab your calculator and ask your calculator what the cube root of 2 is, it's ugly. Fills the screen of your calculator. It doesn't seem to have a pattern to it, and since it fills your calculator, there's more to it, and it just can't fit it on your calculator screen. So it's a real number, but since it doesn't repeat and it doesn't end, I can't write it as a fraction, so it's irrational. And once it's irrational, that's as much as I can say about it. And our last one, short and sweet, 5. So 5 is real. It is also rational. I can write it as a fraction. It's 5 over 1. It's an integer because I don't need to write it as a fraction. I can write it as just 5. It's a whole number because it doesn't include any negatives. I don't need a negative. If I can't use a negative if it's a whole number. And it's also a natural number because it's one of those numbers that you would start counting with. You will hear it on Sesame Street with our 5. So classifying real numbers, taking a look at which category each number falls into, and listing all of the categories that that number is a part of.